Okay. Are we live? Yeah, looks like it. Welcome, welcome, welcome. Let me get my... turn the music down a little bit. Alright, welcome back to my Game Engine development stream. So, last time was 2 days ago, was my last stream. Last time we got nicer transform components working. So now, whenever you have items selected that are mixed, so you have one item has one value for a field and another has a different one, we'll see dashes instead of the actual value, but you can still set the values for all of these selected items at once. Kind of a nice to have. There is still a problem with it. I had during the last stream come across a couple situations where I went to type in a number and then found that the number would not update whatever was selected. And I figured out what the problem was, and this is actually probably going to need a modification to IMGUI to work. But basically the problem arises from the fact that even when you have selected multiple items, the value of the first selected item is still known or held by the box. Hey Yoshi, welcome. But when you go to set the value of the box to be identical to the value of the first selected item, IMGUI doesn't think that you've changed anything. So it turns out that this is a thing. I went and did a little bit of Googling and found that there's an unimplemented feature that's intended to solve this. So at some point, I think I'm going to go back into IMGUI and actually just like implement the feature and then make a pull request so other folks have access to it. I'm trying to find the card. Here we go. It would be this guy. Basically, this is probably a pretty common use case for transform components, is to be able to have mixed values that you can type a value, no matter what value it is, it'll update all of them. That's exactly what this question was about. And the author indicated that there was a flag called I'm GUI item flags mixed value, that if you set it, it's supposed to make it so that you can do this, but it's not been implemented for drag sliders yet. So at some point I'm gonna probably have to do that myself. But that's a back burner item. Whoops. So I don't really care about doing that right now. But yeah, that's where I'm at. I went ahead and submitted the changes that we did last stream onto the Git repo. So if you wanted to access and build Enterprise yourself, you can now as long as you have a system for it, you can edit the positions, the transforms of your entities. Still not super useful yet because we have a lot of work to do for features in the editor, and that's what we're gonna talk about now. So I'm moving from Visual Studio Code to IntelliJ right now. Nice. Let me know how you like it. Yeah. So I took the better part of yesterday to kind of decide what to do next now that we've got this going, because there's a whole bunch of directions to go. And I've actually I made a list of all of the directions we could go. So there's a whole bunch of things that we need to do to integrate systems a little bit better, so that way we can work with systems, even custom systems inside the editor. There's also material systems. Basically, materials are like shaders plus the data that you associate with the shader. So you have a shader that you can supply like diffuse, reflection, specular, and all those values to, and then a material is that program plus the values you supply to those parameters, to those uniforms. I decided that I wanted to do that at a lower level than systems. So that is, in Enterprise, you'll have a universal material system that all renderers can use or utilize. So that's a thing that's going to be a core engine feature. Hot reloading is obviously a core engine feature. Basically, when you're working on your game code, the ability for it to affect the editor and the launcher without having to reload those things by quitting and relaunching your game. Project properties. This is the feature where we're going to have resource compiled property values. So similar to how you can set properties of your project in Unity and Unreal and other game engines, it'll be like a menu inside of the editor. However, one of the big differences is that it's going to be resource compiled, and by that I mean it's not going to be saved as a data file. It's going to be converted into C++ code and then injected into the final binary when you go to ship your game. So there's that. There's the new console. At some point, we're going to need to get logging to appear in the editor instead of inside of your debug console. And then there's dragging and dropping stuff in the inspector. Right now, the hierarchy just shows a list of entities that's in the scene in the order that they are specified in the file. So in this case, it's just the order of it's sorted by entity ID, basically. However, this is not how you actually want to work with it. You want to be able to click and drag and move these up and down, and you also want to be able to nest entities. However, I think it's probably too early to be working on something like that, considering we don't really have anything for these entities to do yet besides display sprites. So I kind of reviewed all of the things that we could be doing, and I think that even though it's the biggest item on the list, adding integration for systems into the editor is probably the top priority. So right now, we've only got one system, It's something that's actually shipped in the the engine layer code, though I may branch it off in the future. That's Renderer 2D. Its entire thing is that it's a batch sprite renderer, basically. You give it quads, you give it a texture, you give it a UV coordinates, you give it the filters for minification and magnification, and then it uses those to draw a quad in the scene. And it batches them as well. So I have it right now just displaying entities. I have attached sprite components to each of these entities in the scene file. Renderer 2D manages those components. So when you call init on it, it takes and allocates the memory for the CPU side sprite data. And then it registers a scene draw function, so that way whenever you go to draw a camera view of the scene like this, it will render these components. And then it registers the component type sprite, gives it the pointers to all of the functions that Scene Manager will need in order to tell Renderer 2D to do things. So this is probably going to be our primary interface. One thing that is sorely missing is the ability to interface with the editor. And there's a bunch of different ways we could go about doing that, about going through integrating a system with the editor. A lot of folks are familiar with Unity's style, and I might as well just leave the demo project open again for demonstration purposes. But in Unity, set my temperatures. In Unity, when you make a component, you're basically making a script, which is behavior and data for your component. And that lends itself well to using reflection to set up an inspector view. You can basically, you just mark anything that's anything that's public can be already made visible to Unity, and Unity will say, okay, this is a public field, let's make it visible in the inspector. And it can also use the attribute, I think it's show in inspector, on private members as well, and display things that way. I think that's great. I think that's easy. However, it doesn't really apply to ECS because the components are not behavior and data. It is just data. And more importantly than that, or more to the point, the data is 100% managed by the system. So if you're comparing components from one system to the next, you can't really make any general statements about how that memory is laid out in RAM, about how the components are laid out in memory, I should say. So for example, in the one system we have right now, we have sprite components, which is a pool. It is resized to the value max sprite components during initialization. And then from then on, we access the sprites by index. So when you go to create a sprite, what it does is it grabs a sprite out of the pool and then marks it as in use, basically. And a lot of systems are probably going to work that way because pools are just so efficient. But you can't make any general statements about how a system might handle the memory of its components. So knowing that, a system like Reflection, where you just have Enterprise automatically read out the values that are inside of a component and then display them in the inspector, that's not going to work because Enterprise can't have. It's not that it doesn't, or that we haven't done it yet. It can't have any picture of what the memory model is without the system telling it so. So my choices here are either that the system while it's registering its component type, gives Enterprise through its API a complete picture of its memory model, which how do you do that without tying a developer's hands? Or we push the responsibility of drawing the inspector onto the system. And that's not even unheard of within Unity, because a lot of times when folks will come up with their own scripts, they'll use something called a property drawer to customize the UI of their script inside the editor. And that kind of like overrides the default behavior of having Unity pick out the public fields and the serialized fields to display in the inspector. I'm going to turn this music to something a little more chill. I seem to always come back to this one, but it's just so good. Alright. So, at a fundamental level then, we're talking about an API in Enterprise that when you write a system, you tell that API to extend the editor. I'm thinking something along the lines of an editor namespace inside of the engine. We're going to need to be adding an API that's specific for communicating with the editor's interface. So we'll need to have some namespace or something like that in here, as if it's a system. So it'd be like editor register inspector view, and then you can pass in the hash name of the component type like this, or maybe just the string name. I don't know. I'm on the fence about that. And then you pass in like a function pointer to something that'll handle the GUI. It'll be like on editor GUI or something like that, or on inspector GUI. And then that from this point on, when the inspector wants to display details for an item or a group of items, and all of those items happen to have a sprite component, an inspector, then this function would get called, and then the system can draw its section of the inspector. And that's great. I think that's great on paper, but it does present some problems. The first being, how do you draw your editor? How do you draw your inspector view? Basically, you would need to have a method. I'm just going to continue this metaphor. Void, I'll do static void on inspector GUI. So this would be like the callback for your registered inspector view. You would need to do something in here that displays the stuff, meaning that we need to have access to an immediate mode GUI interface. There was 3 approaches I could think of to handling this problem. The first would be to just use IMGUI by itself. And I'm probably going to have to do something like this. Right now, Dear IMGUI is only in the editor layer. That is, it's a submodule of the editor project, and it's added via its CMake list. We don't actually have it visible inside of the game project or the launcher project. It's just inside of the editor. We would have to push it a little bit higher in the dependency tree, so it would have to be visible to the engine layer, so that it would be visible to both the game and the editor layer, if that makes sense. So any systems that I'm going to ship with the Enterprise Engine library that are part of the actual DLL will need to be able to see the IMGUI stuff. The editor already does see the IMGUI stuff, but it will still need to. And then the game layer itself, because we're talking about the possibility of adding game-specific systems. So like a portal system or an AI system or something like that to your game project. The game project then also needs to see IMGUI, and that's part of what we're going to have to do. The alternative possibility, which I'm going to dismiss immediately, but I'm going to explain why I did that, is to make my own. So it'll be a proprietary GUI library. And I don't like this much at all because it's another thing for developers to have to learn. And in order for me to offer anything robust, I have to spend a good amount of time working on just a GUI library. And given that I'm already using IMGUI for my engine, that it's a little bit like reinventing the wheel. It's not a huge ask necessarily for developers to learn the ropes of a GUI library, as long as it's done as long as it's organized in a easy to learn way. But it's a thing that I don't really want to ask people to do. It's a thing that I don't want to do. I don't want to be spending time making a GUI library when I want to be focusing on other more interesting things. And that kind of leads us to the last item, which is kind of like a mix of both. As much as I like IMGUI, my experiences with it so far show that it doesn't cover all of our bases. It just doesn't. I've had to modify IMGUI pretty much so that I could gain access to lower level Windows stuff. So we're using an enterprise specific branch anyway. But things like raw mouse deltas are not captured by IMGUI. The ability to trap the mouse is not covered by IMGUI. And these are all things that you'll probably want to have when you're making your game systems. So if I've got an inspector view and the thing that I'm dealing with is like I've got like a widget inside of the component that's like itself a camera view or something like that. And that's totally doable, by the way. You can just like have a fucking camera inside of your inspector. You need a way to be able to trap the mouse like I do when I right click on the scene view, to make sure that the mouse doesn't find its way outside of the window when it's hidden, and things like that. So in order to have access to that low level stuff, IMGUI is insufficient. So instead of doing just IMGUI, I'm going to say IMGUI plus, how about that? Where it'll be, basically you'll have access to all the IMGUI stuff, but then you'll also have access to a small library of helper functions. So helpers in the sense that they can wrap the IMGUI code to make something that's a little bit more in line with what we do inside of Enterprise. Because remember, even doing something like the transform in the inspector, even doing something like this required quite a bit of code. And if we wanted to have something that matches the style, maybe you'll need to have a helper function to handle that. Where was it? But then also in the sense that we would have lower level stuff like raw mouse deltas, like the ability to lock the mouse in place, things like that. Man being sick sucks. Oh man, you're sick? How are you doing? But anyway, yeah, this is what we're going to be looking at doing. So first goal then is to get IMGUI visible to all the projects. So we're going to migrate it from the editor layer to the engine layer, and then we're going to be working on abstracting a API for some of the things that we need to extend. What are you sick with, Jolo? If that's not too personal a question. Okay. All right. so let's start with the organization part. I'm going to open this whole thing in File Explorer because it's a little bit easier for me to picture this problem while I'm looking inside of here. So right now we have the 4 projects. Just to make things simpler, I'm going to delete the data and docs folders. These are generated. I can actually also delete the build if I want, but well, I probably should do that anyway, actually. And then come back to that. Mild fever, sore throat, nothing too special, but still annoying. Yeah, I feel you. So basically, we got these 4 projects. As it is right now, we go into the editor view, or the editor folder, and then we have the source code. We've got content files. We've got resources. Resources are things that are needed by build system. They're not not things like fonts or those kinds of resources, but things that like the icon file, the info.plist for Mac OS, things like that. Inside of the vendor is where we keep the submodules for vendor-specific code. IamGUI is a submodule from the enterprise fork of Dear IamGUI. We now need to move this up into the engines vendor section here. And then we need to integrate it into the build system in a slightly more reasonable way. So how do we do that? Because it is a submodule, I can't just copy and paste it and have it all work. I do need to change the path. I think it is technically enough for me to just come in here and then change the path inside of the .get modules. But I actually need to have, even if I update this, I need to have my local Git repository understand that that's where that is. So there's actually Git commands for this, and I just don't remember what they are. Git move submodule. How am I moving an existing Git submodule within our Git? This is what Stack Overflow is good for. It's the only thing. It's for Googling how to do things that are covered entirely by the tools documentation. Since Git 1.8.5, Git move old submod, new submod works as expected. It does all the plumbing for you. Okay, so basically we just use Git move, and that brings it over. Let's do that then. I'll use the terminal inside of VS Code. So we'll say it was Git move, and we're going to move from editor vendor IamGUI is the submodule, and then put it in the new location. That's going to be engine vendor IamGUI. All right, let's confirm that that did what we thought it would. So inside the editor, inside of vendor, IamGUI's gone. Engine vendor, IamGUI's there. We take a look at the Git modules. Where is it? Here. Yep, so now it's in the engine vendor IamGUI. So cool, we've moved IamGUI over. It's staged as well. So basically we just need to commit this to say we moved IamGUI over. However, at the same time as these changes, as the change of moving the submodule up to the layer, I also want to commit the changes to CMake lists that makes this work. So we're going to go to the editor's CMake lists. And I'm looking for IamGUI. here. IMGUI is a little bit different from, it works a little bit differently from some of the other CMake projects I have, because IMGUI is actually just, you just include the files in your project. That's how it's supposed to work. You don't like invoke CMake add subdirectory or whatever it's called to include it. You literally just locate the files and include them. So I'm just going to cut that whole section out. We're going to go to engines CMake lists, this guy, and we're going to need to add these to the vendor source code. And there's another section in here for that. That would be here, vendor. So right now, vendor headers, vendor source, and all that, that's got the compile time spooky hash, and it's got glad. And also STB image, which STB image is also it's a header only library, but you do have to have an implementation in one of your source files, so I added one. And we just got to merge these into here. Though, now that I'm thinking about it, these should actually probably be in their own category. The reason why I split up my source files into so many lists is because I conditionally include them into various targets, depending on what they are. Previously, all of my vendor headers and vendor source, all of this stuff, had to be included in both the static and the dynamic version of the enterprise library. However, we're only ever going to be using IMGUI in the editor. You could argue maybe that you'd want it in the launcher as well for certain things, but it's not the intended use case that you use this in the launcher, just that you use it in the editor. And because these are only going to be utilized inside of the editor, it actually only makes sense for this to be included in the static version of the enterprise library. So these probably should be maintained separately from the rest. What we'll do here is we'll do the same names as before, and then we'll underscore and say dyne for dynamic. And just to make sure that I'm in keeping with my previous naming schemes, because I know that I've done something similar before. Yeah, I did underscore lib for static, and I did underscore dyne for dynamic. Cool. So now we've got the we've copied over the files to include. Because this is coming from the engine directory, the engine /vendor /IMGUI, these paths are actually still all correct. And now we need to include them in the right locations and remove them from locations where they no longer belong. So all this stuff needs to go. What was the other one? Oh, the other one was native file dialog. That's fine. Cool. So we no longer have editor vendor source or editor vendor headers. I guess it's just all source, engine headers, protected headers, editor vendor, editor resources, editor content. Yeah, so we'll comment that out for now. And then we'll comment out the IMGUI include. We're no longer referencing IAMGUI directly from the editor layer. Instead, we're going to make it a public include on the engine, and then that'll propagate down to all projects, including the editor. And then we need to add these. We need to add these to the target for engine dyne. So we've got vendor headers 132. We need vendor source dyne for this project. Okay, so we got vendor headers 132, vendor source 132, and then we've got the dynamic versions of vendor source. And that adds these only to the dynamic version. Cool. All right, we're getting there. And now we need to add to the target include directories for engine dyne. We publicly add vendor/IAMGUI. And what this does is that every CMake list or every CMake target that's based on this target that uses this target as a dependency. So that would be the launcher, the test game module, and the editor. They will also reference vendor/IAMGUI for the headers. And so that should just work, hopefully. I'm sure I've forgotten something, but if I have, I can't think what. So let's save these CMake lists. We'll run the configuration again. Where's my CMake? That's the CMake language server. CMake build. Okay. Build files have been written. All right, and confirm. Yeah, there's the build folder. I guess moment of truth time. F7. Let's confirm that we didn't break something. Oh, you know what, Jolo? I think I missed your last question. I'm doing fine. Thanks for asking. I was just in the middle of a rant when you asked. Okay, we got some errors, so let's see what we screwed up. Okay, that's actually an error inside of IAMGUI, which is interesting. scanf is deprecated. This function or variable may be unsafe. Well, that's just a warning. And it's a warning. Okay, so we've got a bunch of warnings in here, but no errors. So apparently the errors that we've got are they're not compile errors, or otherwise they'd be parsed out and put into the problems tab. All right, what do we got? scanf is deprecated. Is that a... It's just a warning. Okay. I'm a bit surprised because I don't recall seeing any of these warnings when I added IAMGUI to the editor. But I can't think of a good reason as to why. Oh, hang on. I know why. I skipped a step. So we've got vendor headers and vendor headers 132, and down here we've got vendor source 132 dynamic. So these platform specific items are being compiled onto the wrong platforms. So yeah, so there was this section down here, and I have this in most of my CMake list files, where whenever I've got platform-specific code, I include them in the project unconditionally, so I can always see them whether I'm working on my Mac or on my PC. But I will set them as header only, which just means that CMake will not compile them as CPP files. So these variables don't exist anymore. I'll get my timer going off. I'm gonna need to grab my laundry out of the machine in a minute. But yeah, these items, editor vendor source macOS, these items need to be commented out because they're no longer variables in here. And then on the engine CMake lists, we need to add them. So that'll be these. I'm gonna copy that. And then in this section down here where we don't compile source for the opposite platforms, we will be adding the macOS stuff to be skipped on Windows, and then the Windows stuff to be skipped on macOS. So we'll get rid of, say vendor source macOS Dyn, and then vendor source Win32 Dyn. We'll add those to the respective skip lists. Okay, save. Build files have been, and press F7. Application input.h file not found. Okay, yeah. So we do have a couple of modifications to IMGUI that depend on code that up until this point has lived in the editor layer. So in particular, if we go to the file in question, in particular, it's looking for application/input because I do have the raw mouse messages are being sent to the editor layer when you have the child windows in focus. So this is going to need to move into probably the regular game layer, now that I'm thinking about it. So the regular enterprise input. The trouble with doing it that way is that we actually have a clear separation of input from IMGUI and the game layer. That's been pretty well established. So instead of moving this to enterprise input, I'm going to be moving this to the IMGUI plus layer, where we're going to add helpers and things like that, extensions to IMGUI inside of its own namespace thing. So it kind of looks like this is the last remaining problem, is this stuff. So what I'm going to do, I'm going to head to the, let me collapse all of these, head to the engine layer, head to engine source, and I'm going to add a new folder. This is going to be editor for editor layer interface stuff from the engine layer, from the engine library. We'll add a CPP file. Well, actually, let's do this in the public header section first. So we'll do the interface and then the implementation. So inside of include enterprise, we'll do a new folder. This will be editor. And And because it's inside of the enterprise folder, this is stuff that'll be visible to the game layer. Which is actually not what we want now that I'm thinking about it. So let's go to EP internal for this one. This is stuff that's going to be visible for the engine, the launcher, and the editor. And we'll say editor, and we'll add a new file here, and this will be I guess it'll be IamGUI, or let's call it input. Well, that's a little bit misleading. Let's do IamGUI input.h for now. We'll give it the old pragma once, and then we'll need to move some items from the input layer on the editor into here. Probably all of it, actually. So let's look at that. Source, application, input.h. So we've got the raw mass accumulator, raw mass delta. These need to be accessed by the IamGUI. We also have set mouse cursor position. We have update. What does update do? Update literally just resets these values. So actually, yeah, literally everything from these files can be put inside of that folder. And knowing that, I will actually just delete the new file, and I'll just drag over input.cpp and input.h into their respective locations here. Input.cpp should go in source, editor. Okay. And then I'll rename these for good measure. And as I often do when I'm live coding, I will come up with better names for these before I go to commit them. I'll just give them a name for now that I don't necessarily like. Okay, and now that we've done that, and it looks like the includes are all pretty much sorted, this needs to be changed to IamGUI. Oh, sorry, this needs to be editor / IamGUI input. And then we need to update the CMake lists. So in the editor, we no longer have these input.h, input.cpp, because that's going to be handled in the engine layer now. So we'll save that. And then inside the engine layer, we need to add the new stuff. Where's the... Okay, here we go. Engine source dynamic. So this will be source / editor / IamGUI input.cpp. And then I need to put it in the dynamic headers as well. So we got engine headers, protected headers, precompile headers. Do I not have a dynamic header section? I've got an internal header section, I suppose. Yeah, so I'll put this inside of internal, because internal is here, the protected headers. It's by default, it's intrinsically a dynamic header section. Okay. And so we'll add CMake dir /engine /include / all that business / editor / IamGUI input. Cool. Awesome. So now we've got the IamGUI header in the right place. Let that rebuild for a second. In here, the header doesn't appear to be resolved yet, which is interesting. So this is engine, source, editor, so the editor folder inside of engine. Yeah, it should be able to... Oh, hang on. I know what the problem is. It's in here, my CPP properties. Yeah, so I need to change this to the engine / vendor / ImGUI for the include path to be correct. Yes. Right. Can it open editor / ImGUI input.h? That's interesting. Maybe that wasn't the problem. So editor folder is visible, but that's it. Yeah, that's strange. That should be visible. I'm gonna build it and then see if IntelliSense changes its mind. No, still a problem. This needs to change. So that's going to be EP internal / editor / ImGUI input.h. That'll give it the header containing the raw mouse delta and so on and so forth. The scope is still editor input, which is correct. It should be what we see in here. However, this reference should be fine. So I'm not clear on why it wouldn't be seeing it. It doesn't appear to be seeing anything inside of editor /. Oh, because this is looking inside of the source folder, not the header file. Right. Whoopsie. Editor / ImGUI. Oh, whoops, I don't think I saw your messages pop up. Yeah, I wonder what's up with that. My Twitch is not, or my Twitch thing is not showing everything that you say, I don't think. Unless I was just really inattentive. Huh. I'm gonna restart it. Yeah, but it looks like everything seems to be compiling better now, so it must have fixed all the broken references. We're not getting any warnings so far, so that's good. Okay, we still have a failure to build though. Runtime, okay, so this is in the editor layer. Editor layer is still looking for the same input. It's no longer located in this layer now, it's going to be located in EP internal / editor / IMGUI input. And same thing goes for this guy. Okay. Oh, and IMGUI.h is now gotta be angle brackets probably. We're getting there. So IMGUI.h backends, whatever, all this stuff. That needs to be located a little bit differently. So inside of engine, vendor IMGUI, IMGUI doesn't have a nicely sequestered include folder, so this stuff is just all inside of the main path. But because this is technically an imported dependency, technically this is brought in from the engine layer, I'm going to be putting these in brackets. They're not part of this project. They're part of the IMGUI library, which is technically part of the enterprise library. All right. Good. And I'll do that for all the rest of them. Inside of my files, so we've got scene editor, content editor, okay, so all of these are inside of the editor code. Change those to brackets. That's the there we go. Yep. And then IMGUI internal.h is going to be like that. And then backends. These will be angle braces as well. Okay, F7. There may be a couple more references to the application / include, or application / input, but okay. Undefined symbol, editor, input, update void. Oh, right. So this stuff is now part of a DLL, so the symbols need to be exported. So we're going to do include enterprise / core / shared library exports, and then that'll give us the ability to do this. Yes, and all of these will need to be visible. Like that. Good. Okay, what else we got? chat overlay running? It looked. Yeah, quickly send myself a. Okay, it's appearing now. Hopefully that'll be the last of the problems with the overlay. Okay. Link error, undefined symbol, IMGUI, IO. Okay, now all of the IMGUI symbols need to be exported from the DLL. So we'll need to find a way to do that. I'm going to quickly check the Dear IMGUI README, because it's possible that they've considered this already. Generally speaking, when you're using Dear IMGUI, you're statically you're just including the source files into your project. You're not having to export symbols. However, in my case, I need it to be part of my engine's shared library and then visible to anything that would link it. So I need to export the symbols from Dear IMGUI. Doesn't look like this is part of the Q&A. So let's just take a look at the headers themselves. So let's go to imgui.h. So we do have this macro imgui API. Okay, define attributes for all of API symbol declarations, e.g. for DLL. Okay, so they've got the boilerplate in here for the most part. Using Dear IMGUI as a shared library is not recommended because we don't guarantee backward nor forward ABI compatibility. And I'm actually okay with that because in my use case, as in a game engine library, you're only ever going to be using a compatible version of the game engine library, because the game engine library itself will be what has the IMGUI source code in it. So the ABI has to be, I have to do my own guarantee for the ABI for my library, so that's not a concern for me. Do I have to override this? Kind of looks like I have to do my own definition somewhere. Okay, here we go. imconfig. Right. So this is the section where you can, where you have all the things that you can define and undefine to modify the behavior of IMGUI. I already have, for this branch of Dear IMGUI, I have actually uncommented the disable obsolete and disable obsolete key IO because as a new user of Dear IMGUI, I'd rather just not use anything that's obsolete, and this disables things that are obsolete. It looks like here I can actually do the same thing. I can do a definition of IMGUI API. So this is going to be a little bit a little bit messy. I'm going to need to replace these calls with my own conditionalized compilation. So let me look at shared library exports and double check how I had it done here. So first we have condition for Win32, so we're only doing this logic on Win32. Otherwise, it's just not, you don't do anything at all, because on macOS it automatically will export the symbol. We don't export when we are compiling when we are compiling the static version of the enterprise library, and we will do export when we are building internally, and then we'll use import when we are using the header externally. So that makes sense to me. As it is, we are already not including the source for IMGUI in static builds, so this secondary check is probably unnecessary, but the rest of it's good. So we're going to use it as a template. Head back to imconfig, and then instead of doing EP API, we do IMGUI API, like that. Then I'll replace this comment with, well, I don't need to replace it with anything. I can just get rid of the comments, because this is not part of my API. People are not going to be looking it up inside of my documentation. Okay. We're getting somewhere. This is technically not my code, so I do want to match their style a little bit. I think the ifdefs in their case don't do nesting like this, but I'll leave that in. Yeah, so in their cases they do no nesting on the ifdefs. But they also don't do a lot of nested ifdefs. Okay, here's some. If defined. Okay, but this need a file dialog. Yeah, fuck it. I'll just leave it in. Alright, so now we've got IMGUI API exporting when we are in the core and importing otherwise. Yeah. I'll leave that as it is. Let's try building. Alright, what do we got? scanf is deprecated. An issue with stdio. Huh. That was kind of unexpected. So in backends, IMGUI implementation OpenGL 3.cpp. We got a bunch of deprecation warnings again. Well, we got a bunch of deprecation warnings, but it is compiling. Basically, the IMGUI implementation uses string copy and scanf, which is considered unsafe on Windows. But it still works. Oh, you know what? I think I know what's going on. I think that I had silenced these warnings because I wasn't going to refactor the entire IMGUI library to silence this warning. I just put in an _CRT secure no warnings into the defines on the editor CMake lists. Or did I? Define. Huh. Okay, well I added this to MSDF Atlas Gen. But nowhere else? That's interesting. That's weird. Because these are all IMGUI. Huh. Well, I'm not really clear why, but I didn't... Even though I didn't mark these... Even though I didn't silence these warnings for the IMGUI library in the editor project, the warnings only have appeared when I moved to the editor project. Okay, I'm going to put that on the back burner for the moment. I'm going to at least confirm that the editor works. Okay, so we got the IMGUI demo, window, content, window, inspector, hierarchy, goes on top of the inspector, the game view, and then the scene view. All right. And let's open up a scene. Ta-da, okay. So at the very least, we do have IMGUI successfully migrated. I'm gonna take a look at silencing those warnings before I do my commit. But yeah, once we've got that going, we're gonna want to take a look at setting up a system by which game systems like Renderer 2D can extend the inspector with their own things. I'm gonna take a quick break. I've got to take my laundry out. I'll be back in like 10 minutes probably. All right. Alright, I'm back. Good. Alrighty. So where were we? Yeah, so we got everything working. We've got IMGUI moved to the engine layer, so now it's visible inside of the engine layer as well as the game layer, as well as the editor layer, and so forth. However, we do have a bunch of these warnings in the output. Basically, we have a couple of deprecated functions that have been used throughout IMGUI that haven't been fixed in IMGUI. So what we're going to do is we're going to just silence the warnings because there's nothing we're going to do about them. We're not going to refactor IMGUI just because of these warnings. So on these are both the engine layer. Here in the engine side, we're going to go to the target definitions. Here we go, preprocessor defines. So you got the definitions for engine dyne and engine lib. Oh, this is a bit of a toughie. See, I want to use the define CRT insecure deprecate, but I don't want to do it for the engine and everything else. I just want to do it for IMGUI. And that's not really possible from this perspective. Because we're not making an IMGUI DLL, we are making a enterprise DLL that includes IMGUI source. So if I was just to add the deprecation warning to engine dyne, that would silence the warnings, but it would also silence the warnings for all of my code. And I want to see those warnings for my code. I want to be heeding their warnings if there are any. So I guess we'll have to approach this a slightly different way. We could move IMGUI into a DLL for starters. We can make an IMGUI target and then link that into all the projects, and then set the define inside of its CMake lists. But I think instead what I'm going to do, I think I'm just going to add it to the configuration file, because I think that's included everywhere. So let's look for that. Engine, where's IMGUI? Here it is. So I believe that imconfig.h is included everywhere. Configuration file with compile time options. Edit imconfig.h or pound define imgui user config with your file name from my build system. Right, so I can actually, because I am modifying this file to include all the definitions we need, I can actually just define the CRT deprecate in here, I think. So let me do that. And let's see whether that gets rid of all of the warnings. Check return. C++ requires a type specifier for all What? Is there a multiple declaration thing going on? That actually broke compilation. I for sure wasn't expecting that. CRT insecure deprecate macro redefined. Previous declaration is in VC runtime.h. Okay. Got it. So by the time ImGUI or imconfig.h is invoked, VC runtime.h is already included. So that means that this is too late to define the deprecation silence warning. First let me recompile so that it's not broken anymore. But let me look online, see if anybody else has hit this particular snag. Surely there's got to be an open issue for it. Oh my gosh. Hang on. I actually... I copied the wrong thing out of the box. Maybe this will do it. Let's try it out. Okay. So it looks like this is not included in all the implementation files. In imGUI tables.cpp, we've got if defined. Oh, that's weird. So the implementation file does itself actually define CRT secure no warnings. But we still get the warnings. Okay, so I wasn't imagining it then. Something about how I am including this implementation has made that define invalid for some reason. It's a little confusing. Okay, so imGUI implementation OpenGL3.cpp has this in it: if defined MSVC ver and CRT secure no warnings is not defined, then it defines it. So that should be it. This should mean that we've got these warnings silenced, but they're not. I'm looking a little more closely at the command line that led to these warnings. Okay, it doesn't actually give me the command line. I was thinking that it would tell me like which target was being compiled, for example. Let me try something. I'm gonna temporarily switch my configuration provider back to CMake Tools. So that CMake Tools is calling the shots on what's included in what. And then I'm going to change my build target to just the engine dynamic. Hit F7 and see if the warnings go away. And it kind of looks like they did. Function call not allowed in a constant expression. Yeah, that's not what I cared about. And then if I go to build the static version, F7, don't have any output. Go to the launcher, press F7. No output. I'm going to build these one by one and see what I got. So what I'm going to do is I'm going to clean my build folder, so that way we're building everything from scratch. Cleared out all the built files. We're going to start by building the engine DLL by itself, and the target that generates these warnings I should be able to see pretty clearly, and that might tell me something about why I'm getting these warnings. Maybe there's like a something about a particular target. Okay, so actually right out of the box, engine underscore DYN. So building the dynamic version of this library immediately causes this problem. Okay, let me go to the affected file. All right, so this is where we normally have CRT secure no warnings defined. We're still compiling, so IntelliSense is being a little bit slow. So we do have MSC version 1929. So that is defined. And, well, if CRT no warnings, secure no warnings is undefined, then it gets defined. Why isn't that the end of the story? Okay, so CMake Tools and everything else seems to think that CRT secure no warnings is defined. But for some reason or other, it's just not working here. And it did work in the other project. I don't know, maybe this is something I shouldn't be fussing over, but it seems like a serious red flag to me that this wasn't a problem when I had the IMGUI code in the editor, but it is a problem now. I don't understand. It's the first thing in this file, so it should be the first thing. Oh, hang on. I think I know what's going on. I think it has to do with my precompile headers. That's the only difference I can imagine. Precompile headers, basically this is just a list of things that CMake force includes in a precompiled module, and then tells the compiler to include this for every CPP file. What I'm thinking is that somehow or other, one or more of these headers is being included prior to this definition, and because of its prior inclusion before all these other headers, CRT Secure No Warnings is not disabled for some of the stuff in these headers. So maybe something in stdio, for example. Because scanf is... Which header is that? That's, I think that's a CIO. Yeah, stdio. So... Okay, yeah, that's the problem. So previously, the IMGUI stuff didn't have a precompiled header because the editor project didn't have a precompiled header. These are being forcibly included in the IMGUI CPP files before it has a chance to silence the warnings. Okay, that makes sense. So what I need to do then is I need to take the IMGUI source and I need to exclude them from the precompiled headers. Yeah, down here. So, okay, I'm glad I went through all this because this would have been a headache down the road. So basically this is done with set source file properties. We take the project, we take all of the source files that we care about. We set skip precompile headers to true on them, and then when they go to be compiled, they don't get the precompile headers in it. So we just need to do that again for the correct target. Files. Okay, I wonder why I split this off into two lists. I don't see any good reason for me to have done that. Files. Yeah, these may as well be one list. Properties, get precompile headers true. Yeah. Let me combine these into a single list. And then I'll add to this list vendor source dynamic, macOS dynamic, and Win32 dynamic. Okay. This whole list. Okay. All right, so now all of the IAM GUI stuff, all of the vendor stuff is not dealing with precompile headers. Hopefully all these warnings will go away. Man, that was complicated. All right, cool. Now we don't have those warnings anymore because IAM GUI is able to silence its own deprecation warnings. Cool. All right, I think we're off to the races. Let me switch the build target back to all. Hit F7, and we'll rebuild the rest because I cleared it out in pursuit of this experiment. And once that's done, I'll get the commit made for moving IAM GUI over, and then we will start doing the system integration stuff. All right, we're getting there. It won't be long before we're doing cool things in the engine. Yeah. While that's working, let me pull up Scene Manager. Now let me pull up Renderer 2D. I'm going to use Renderer 2D as the test bed for this because it's the only system that I've already got implemented. In that it actually does something in the editor. Cool. Build's fine. So let me move the demo window out of the way. Let's open up the scene file. We got all of things. So our next goal is to add an API by which the inspector will show details for a system's components. If we look at the init function for this system, and just as a reminder of the paradigm that we're following, the entry point of a game project will have game sysinit, and you would tell Enterprise which systems that you want to initialize at that time, whether it's your own system or not. During initialization time, we set up all the memory that we need to manage all the components. We then register a scene draw function, so that way when the scene goes to draw, it can add things to it, so we can see sprites in the scene. And then it registers the component type here, which is basically about serialization practically speaking. We pass in a delete sprite component, a serialize sprite component, deserialize sprite component, and then get entities with sprite components. And these functions are all ways for the scene manager to get or operate on components defined by this system without caring how they are allocated and how they're laid out in memory. Because you just invoke the pointer to delete sprite component, pass in the entity ID that you want to delete the components from, and then it just does it. We need to have, and it looks like I have some from forever ago. It looks like I had thought about this, and I put in some mock code that I never commented out or commented back in or deleted. So my original thought when I was developing all this was that I would have something like editor, register, component, inspector, or something like that. And in this case, I think back then I was imagining I would be doing like a reflection thing where I tell it the types of data that it needs to change and so on. But for the reasons we talked about at the very, very beginning of the stream, that's not really going to do anymore. There's also this thing about register view mode. That's a topic for another day, but we'll have to come back to that as well. But what's kind of clear from all this is that we do want to have an editor namespace for this stuff. So when you're in your game code and you're writing a system, you do the stuff to interact with the scene manager, And then when you want to add details to the editor, you just go like editor, like add window GUI func or something like that. And then you tell the editor, hey, I have an extension for you. Please use it. So I think that that's going to be the same namespace in which I do the API that I've got to commit now. Heading back to, where are you? Enterprise. This stuff, IamGUI input. This is really not IamGUI code per se. This is more like an editor API that technically has to do with input. And the update is called by the editor, I suppose. What I'll do is I'll add to the public API, so in engine include enterprise. Wait, is this the right? Where's my other headers? Am I filtering these somehow? Oh, I'm in my Git changes, that's why. It was only showing the files I had changed. Yeah, so in the enterprise folder inside of here, we have the editor folder for editor / whatever. I'm going to add just a basic editor.h to the main area. Keeping it in line with the structure that I had before, where when I wanted to include a specific thing, I would say enterprise / whatever that thing is. So, hey Miguel, welcome in. So it'd be like enterprise / and then editor.h is the idea. And do all that. My internet was so slow last time I asked you about SFML. Yeah. Remind me what you were asking about SFML. Couldn't hear my answer? Okay. Is my audio better now? Can you hear me fine now? I think I will turn the audio down a little bit on the music. Yeah, back to where we were. What was your question about SFML? Probably fine. I'm a little on the fence about using editor as a namespace because technically I've already got that happening in the editor layer, but I don't know, we'll make do. I was thinking about using SFML for my very first C++ project, or my very first project I can deal with C++. I don't know too much about IamGUI. Yeah, I'm afraid that I don't have strong opinions on this. I know I have some friends that are real big fans of SFML. That it helped them get started, on projects that they were actually interested in. I just haven't ever used it myself. If your goal is to just do OpenGL stuff, I think there's lighter weight solutions. But if you just want to do something cool and graphical with C++, SFML might be a good choice. I don't know how easy it is to learn though, because I've never learned it. If I remember correctly, it is heavier weight than stuff that's just windowing libraries, like GLFW is a lot lighter weight from what I understand. Yeah, basically just a interface for multiple media systems. System, window, graphics, audio, network. Yeah. Yeah, I don't know if it's really got a place in big projects, but for your first project, sure, totally. I wonder if they have like a used by section, like a section that says, "Oh, look at all the projects that use this," or something. Looking at the README, for example. External library is used by SFML. It's used by STB. Oh, that's interesting. Oh no, this is stuff that it uses. Okay, never mind. I was like STB image uses SFML. It's the other way around. But yeah, it's like at a certain point, if you're doing something big, then you'll probably want to roll your own stuff for the most part. But I don't know. I don't know if that's what you were asking, or if that helps you gauge what you're trying to do. So inside of this section, I guess it would be EP editor. I don't really like that. One powerful strategy when you're doing API development is to start with writing like the use of the code, and then from there deriving what functions you need to expose. So I'm gonna hop back into Renderer 2D real quick. Find that section here, the header. I like the idea of doing editor : whatever. However, this only applies because this is technically inside of the enterprise namespace, whereas a game system wouldn't have that. If we were inside of a different section of code, let me just do a quick function up here. Void example. So this is something that's outside of the EP namespace. So it might be in your game's namespace, for example, if you have a project-wide namespace, which you probably should. From here, I would want to be able to do editor : whatever. It makes sense for me to do EP graphics for things like part of the enterprise API, but doing something like this, EP editor, that suggests a correlation between these two things that I don't really like. I like the idea of informing, like suggesting through the fact that these are completely separate namespaces, suggesting to developers that this is not going to be part of your shipping games code. So I like that quite a bit. So I think in the case of the editor API that's exposed into the engine, I'm actually just going to do namespace editor. But that's, the namespace we use inside of the editor itself. So I'm wondering whether that's going to be a problem. Like if we look at the inspector, for example, this is all inside of editor views inspector. So I guess we do make use of sub namespaces inside of the editor project. So we do already kind of sequester out or segment out things that things out of the global or the outside of the monolithic editor namespace. So I guess you could consider it safe, editor : so you just continue to use the editor namespace inside of the editor project. Yeah, I'll just use the same namespace and live with it. So inside of here, we would have EP API, void, and then it would be like register inspector something. Did I come up with a better name for this when I was brainstorming yesterday? Doesn't look like it. So it'd be like register inspector GUI or something like that. And then it would take a function pointer as a parameter. This would be like I don't know, on, I would say inspector GUI callback or something like that. And of course, for this to work, I do need to include enterprise / core / shared library exports, so that way we have EP API. And then I need to include this into the project for it to actually include that header. Okay, let me disable my configuration provider again because I forgot that I left it on. Okay, I think that's probably fine. We would need to make this. We would need to define this inside of ineditor.cpp. So let's add that. Okay, and here we would do include enterprise / editor.h, and then we would do the implementation. Like that. So simple framework for this, for the second. And then how would this play with the input stuff? I think we're going to need to do both a protected and a public header for the regular API. There is an update call that is going to be private, but we're not doing classes anymore for systems, so we're going to need to put this inside of a namespace, inside of a private header or a protected header. But the rest of this, set mouse cursor position, that could be public, because if you're working inside of the on GUI call, you're going to want to be able to do things like trap the mouse inside of your inspector view. So let's split this up a little bit, and then I can, with that level of organization, I can go on and add the changes that we made for IMGUI into the editor layer, or the engine layer. I can get that committed. Okay, so let's add in here editor.h. We already have a public editor.h, and we have an internal subfolder, which we'll come back to. And then inside of the EP internal, we'll have the protected stuff. So we'll do namespace, editor, just editor, and then we'll have include enterprise core shared library exports for this thing. Good. Set mouse cursor position will be public, so I'll cut that out, and then find the editor folder inside of the enterprise includes, and we'll do I guess we'll call this GUI input.h. So it'll be, when you go to use it, it'll be include enterprise editor GUI input for that stuff. Do pragma once, namespace to editor, and we'll paste in the set mouse cursor position business, including enterprise core shared library exports. All right, cool. This is input related and is protected because we're going to be updating this from the engine layer or the editor layer, and we don't want to see it in the game layer. But we do use it in the editor layer and the game layer, so it has to be protected. Okay, that's good. And we're going to want to rename this to match the other header, which is now just GUI input.h. Okay, good. Looking good. All right, and we just need to make sure that everything is defined in the right locations now. Let me close some of these extraneous windows. And then we need to go into, so editor.cpp has that one call from the public. We do have a private version of that header though, which includes the update. So we should include it instead. So instead of enterprise, we do ep internal /editor.h. And that gives us both the update and the other, or at least it will once I've got include enterprise editor.h. And this is a EP internal header, so we do need to use angle brackets. Oops. Because these will be imported into the editor later on. Good. Now this file has access to this file, which has access to this file. So we have both the public and the private stuff in the CPP. Good. So we got register inspector GUI and update. Update needs to be brought into this file. Currently it's living in GUI input.cpp, which itself needs to be renamed to, this will be GUI input.cpp. This needs to be renamed as well to be GUI input.h. Good. And update, we're going to cut you out, put you in editor.cpp down here. And we'll need access to the internal editor GUI input.h in order to gain access to this private stuff. But you know what? This should probably live inside of, now that I'm looking at it. No, I'll keep it here. Okay, that's looking good. That structure is looking nice. And then inside of GUI input.cpp, we've got the EP internal header, which gives us the this guy. Okay, and this gives us the public one. Okay, public API, private details. Good. And then those are both defined in here. There's the private stuff. There's the set mouse cursor position. Yeah. Which we still haven't implemented on macOS, but I'll deal with that later. Okay. All right. Good. Now we just got to get the CMake lists to be looking correct. So we'll go to the engine CMake lists, head up to this stuff. When we're doing the source, we're going to have now a couple of things. Source editor .h, .cpp, and then editor / GUI input.cpp. And then we need to add the headers as well. Yep. And those would be we don't actually have a dyn headers section. Oh, because that's the same thing as protected, that's right. So in protected, we need to add include EP internal editor .h, and then editor / GUI input.h. Good. And then we need the public versions as well, which, ooh, that's a little... confusing. It's occurred to me now that the headers, we may want to include those headers in code that uses the standard, that uses the static version of the engine library. So like if we're making a shipping game, technically speaking, that's done with the same code base. So in places where I might want to have editor headers, I have a decision to make. I could just let anybody do enterprise / editor.h or editor.whatever. So when you're making a game system and you want to interface with the editor in some way, you just do enterprise / editor.h or editor / GUI input or whatever editor header you need. However, because this stuff is inherently invalid in shipping games, because it's all about it's only stuff that is used by the dynamic version of the engine library. Technically speaking, I currently have this as a compilation failure at this point. Because if we include this header, we'll include this declaration, but no definition anywhere. So I would need to do something like this. ifdef ep build editor or something like that, and if to protect that code from being built into the static. And I'm on the fence about this. It's not unheard of to ask developers to do this kind of a thing, but it would be a little bit weird to require it, I guess. Because going back to our perennial example of Unity, if we go to a script in my project view, just for example, if I open up my test win system, well, that's a scene, not a script. Scripts. If I go to my win system script and launch it, you'll often do like if Unity editor or something like that. So that way that you're not compiling that code in a shipping game. And that it doesn't look like I've got it going on here, but that looks something like this. It's like if Unity editor, like this, and then if. And then everything in here is only compiled when you're working in the editor. And that's not, unheard of, but from what I understand, that's like more of an optimization thing and less of a requirement. Conditional compilation, blah, 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 blah. Scripting symbols, blah, 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 blah. So I think I remember reading this in the like custom editor tutorials in their stuff. Here we go, custom editors. Property doors, maybe. I don't know. Let me search the whole manual for this. Yeah, I'm not really seeing anything inside of the Unity documentation suggesting that they require you to use the if Unity editor in order for things to compile and work correctly. I think that's probably the better approach. So like heading back to Enterprise, maybe it would be better just to do this and then, I don't know, conditionally compile away internally whether they do anything. And that feels wrong to me because you're talking about suddenly if-defing entire files to make them empty. It's a pickle. Because I want this to be available when you are writing your code, but I don't want it to do anything when you're not in the editor. And if I was to just like if-def, EP build dynamic on this guy, how could I do that without breaking your game code? Unless it also uses that wrapper. Yeah. I don't know, I'm on the fence about that. Let me for now, I'm just going to add it to the main headers, see if that compiles. I'll have to mull this question over and then come back. So we've got the protected headers already. Let's add the regular unprotected headers. So these are going to be the same paths, except for it's enterprise, not EP internal. Let's see whether this generates and builds correctly. I think on MSVC, as long as I'm not using a symbol in a particular target, then it's okay for the forward declaration to be made in the header. EP internal editor file not found. Oh yeah, this has gotta change. Yep. 07. Okay, still got a problem. Namespace editor input has no, because it's not in the input namespace anymore. And oh, that's not great. Yeah, we should be putting that in the editor namespace. So this is probably better just to put in GUI input down here. Same thing for the definition. No member named set mouse cursor position in editor input. Did you just mean set mouse cursor position? Have you seen? No, I did mean enterprise. Yeah, this should be namespace editor input. Yeah. All right, that compiled and run successfully. Cool. All right, so we're most of the way there to getting IMGUI accessible in all the locations we need it to be, and all of the custom extensions I have for which are useful for setting up IMGUI stuff, such as mouse trapping, making that available. There's the one hanging question, though, as to how I'm supposed to be conditionally compiling this stuff for the static build. I mean, it's compiling now, to be clear. If I go to test game and run it, this is the standalone. Excuse me. This is the standalone all-in-one exe that doesn't have any DLLs. I mean, it works. It compiles and links and runs. But if and when I have game-specific systems, it may not if we don't handle this problem correctly. So I'm going to take another break. I'll be back in like, I don't know, let's call it 15 minutes. And I'll be mulling this over while I get some coffee. And when I get back, we'll see if we can't get that last question sorted out, get the commit done finally for getting the IMGUI migrated, and then we can start in on what the title of the stream says, which is integrating the systems into the editor. All right, be back in a little bit. All right, I'm back. Got some coffee. I've been thinking this over a little bit, but haven't really gotten very far. So what I'm going to do is I'm going to just sort of go through my thought process on paper, on proverbial paper. I've got to get myself a drawing tablet because it's a little bit nicer for this sort of a thing. So there's a couple of different approaches we can do. So first, let's state the problem. The problem is, how do we allow inclusion of enterprise/editor.h without errors or warnings when statically linking? Feeling better now? Fever went down to, oh boy, yeah. That sounds rough. I'm glad you're feeling a little bit better. You've probably heard all the advice about, drinking water and stuff like that. I hope you start feeling better. Yeah, let me make this a little bit bigger. So the reason why this is not necessarily simple is for a few reasons. The first is that if I wanted to utilize the items from editor.h, this stuff, like for example, register inspector GUI, I basically want this to be a no-op in shipping games. Why would you need to inspect a register GUI if you're making a standalone game that doesn't have an editor, right? So if we were to, there's a couple ways we could make these things no-ops. The first would be inside of the definition, which remember we haven't implemented this definition yet. Inside of the definition, I could do an if-def ep build dynamic, and then conditionally compile away its definition. And this kind of works in a function like this one, where we're accepting, where we're returning nothing. The compiler, the optimization on the compiler may identify that this has no side effects and just no-op it. But that doesn't work very well if it has a return value, and it gets way more complicated from there. And then plus there might be warnings that appear that say, oh, we've detected a function with no definition. So that's not great. How do you give an exe an icon? Oh, that's an interesting question. It depends on your system. I have it set up for enterprise through CMake. The gist is that on Windows, you actually have to, for actual .exes on Windows, you have to resource compile it. So normally when you go to build, I don't think it's showing in my build output. Normally when you go to build, you have to have a .rc file. And I've got one for each of my build targets. And a .rc file is basically something that you would pass to the Microsoft resource compiler during the build process, and it takes and it loads the item into your exe. And if you go into if you're using CMake like I am, basically just make the RC file, you point it to the .ico file, and then you include it in your source. I don't really fully understand the resource compiler. I only ever use it for just icons. But if we go to like the CMake lists for this, you'll see that I've got a section here where I've got I'm adding the embed app icon.rc file, which I just showed you. It's just this one line. And then the .ico file, which is the actual icon. And basically all I do with this is I pass it into the source list for the executable when I'm making the editor. And that's all you need to do, actually. What'll happen is that the compiler, the MSVC compiler, will automatically understand that this is saying that we need to resource compile this into an icon. We'll give it the name icon enterprise. And then inside of your window code, you can then utilize it for your window. But because Windows automatically just picks like the first icon to be the actual app icon, all you need to do to make it visible, like down here you can see that I have this penciled enterprise icon where it's the E but it's white. That's just because I resource compiled an icon, and it'll use the first icon that you resource compiled. It's I might do a tutorial on that later because that's not very intuitive. But there was a particular blog article that got me on the right path for this. I'm trying to find it, and I'll link it to you. It's like somebody did an awesome article on this. Yeah, this is a pretty straightforward guide on this topic. Specifically, you just add it to your RC file. It doesn't actually matter what you name the icon. I named mine enterprise app icon, but you can name this whatever you want, and then you just add it using the CMake source. But let me link that to you, and then later on I'll be considering doing a tutorial of my own because icons are a lot more difficult to do than they should be on Windows, and it's the sort of nuance that a lot of tutorials skip over. But does it also show when you make a shortcut for the exe on the desktop? It does, I believe. Automatically, icons on Windows will extract from the program that you set the shortcut for. So I actually do have a shortcut to the installed version of Enterprise on mine, which is out of date. But basically, when you look at the shortcut, the shortcut will actually extract the icon from the target by default, and you can actually change the icon by selecting a different executable and picking its icon or whatever. But literally what the shortcut's doing is it's reading the icon, the .ico, from the executable. So in general, as long as the executable itself has the embedded icon, then that's that. On Mac OS, it's actually way simpler. On Mac OS, you literally just include the icon file in your app bundle, and then you put it in a text file inside. It's called info.plist. You tell in the text file Mac OS where the icon is and what you want it to do, and it'll just use it. And it's way simpler. There's no resource compiling. You just put it inside the app bundle. But on Windows, you got to go through this whole complicated scheme of generating an ICO at all the different resolutions that you need, and then resource compiling it. And then when you go to make your window, you also have to get the icon from your resource compiled stuff. Yeah, it's a mess. It's not. I don't like it. I don't like it at all. But that's where we're at. Anyway, yeah. So I don't think it's quite as simple as just doing an if-def on these items. I could make it a requirement for folks who are using editor code like this to if-def their use. And if I do that, then I might want to make it a little bit more intuitive. Like inside of test game, for example, if I was to do include enterprise / editor.h, and then try to do something from editor.h, like, I don't know, is there anything in editor that, yeah, register inspector GUI or something like that. What I could do is I could say, all right, I've declared it inside of this header. It's defined inside of another CPP file. When we go to build statically, there's not going to be a definition for this, and so I would just allow compilation errors when you try to use this inside of the shipping code, the shipping target. And then what that would do is it would force developers to do this, to do ifdef ep build dynamic, or something along those lines. And I think I kind of like this idea better because it keeps the headers nice and neat, and it makes it explicitly clear inside of the code, inside of the game code, what stuff is for the editor and what's not. Is there a possibility for the user to give their game an icon? Yeah, so the way that Enterprise is going to do it eventually is that's going to be a project property. So not exactly, not like that yet, because I don't have the build system made for the shipping editor. But technically, yes, the test game does have its own icon, and it has a way to implement it. So in the way that I have it going for the actual build system is that there's a resource file called embed appicon.rc. Right now it just says testgame.ico. And the way that the enterprise build system will handle this is it'll just add the whatever icon file, like it'll add whatever icon file you specify to this file, and then it'll be embedded in that application. And inside of the engine library, inside of window.cpp or window win32.cpp, if we go to the engine side, we actually do have a section here that loads that icon from the resource compiled project. So I have an ifdef here. So if we're doing the launcher or the editor, it'll use the regular enterprise icon, this guy, which has got the nice coloring to it. Otherwise, it'll use whatever you set to icon game, and that's going to be set by your enterprise project properties eventually. But it gets a little bit more complicated than that because there's I need my build system to also portably handle Mac OS, and it has its own entire thing, its entire mechanism for doing icons. But yeah, the short answer is that I can just come in and change this for the test game project directly while I'm developing the engine. But the build system is going to kind of take over the data part of that in the shipping editor. I might eventually support Linux. I've abstracted everything pretty well for the sake of being multi-platform, but I don't have a Linux machine myself. I don't really have any interest in setting myself up with one. But yeah, like if eventually, I think after an MPP, if there's any interest at all in Linux, I'll consider it. But I don't know. We'll see. I think it would be a miracle if this actually, if folks started to use this engine for their own projects for any reason. So adding Linux support is like just not a priority right now. I happen to have both a MacBook and a desktop PC, and so I want to be able to do this on my MacBook, and that's the main reason why I'm doing cross-platform on MacBook like out of the gate, is because I want to be able to work on this on my laptop. But yeah, it's more important to get the thing working than it is to add support for all these things right off the bat. But yeah, I think this is going to be what I'm going to do. I think I'm going to do headers which do the declarations, and then just allow them to break on static builds if you attempt to use these without a conditional compilation flag. Seem to enjoy this, so I thought you might as well do on Linux, right? I mean, maybe. This is not the part that I enjoy, to be honest. It's not. I want to be doing the cool stuff like working on cascading shadow maps, or working on gameplay systems or animation or something, visual and cool. But this is the stepping stones to get to that point. I think it was George R.R. Martin that said, "I don't like writing things. I like having written things." That's how I feel about this. Anyway, so I think this is the scheme that I want to use. Don't save that. Let's make sure that it's implemented that way. So the headers in question are going to be editor .h, .h I said, both of them, and then you don't enjoy the process, you enjoy the result. Yeah, I mean, I guess that's maybe a little oversimplified. I do enjoy coding and the process of coding and having done something, but I think it's cooler to say, to look at this cool thing I did, look what I did, and to be able to celebrate the thing that I did. I think that's more fun than banging my head against the table trying to solve a problem, if that makes sense. Which is, if you think about it, that's what programming is that you make something that's broken and then you bang your head against the table until it's not broken, and then you did it. I want to get to the I did it part, and as quick as I can. But anyway, editor GUI input.h is the other one. Okay, so all these headers need to be handled wisely. The EP internal stuff, that's actually never going to be exposed to the game layer anyway, so I don't have to worry about those. These, however, are going to be exposed to the game layer. Yeah, so these headers can be safely included anywhere, I think, without screwing up anything. Because even though I've marked these for export, the compiler will realize that the symbol hasn't been defined and it's not in use, and so it won't do anything during the linking step. I guess what we'll need to do is we'll need to test this. So I've got a set mouse cursor position call that I can test this on, because this is not implemented yet. I'm going to go into renderer2d.cpp. I'm going to include enterprise editor GUI input, and then I'm going to invoke the mouse trapping somewhere. So during initialization, I think I'm going to do this would be editor input set mouse cursor position. I'm going to set it to 0, 0. And this will set the cursor to the top left is all it will do. If I go to build now, I'm expecting something will break. Okay, and let's take a look at that error. LLD link, undefined symbol, editor input set mouse cursor position. That makes sense, and that's only a problem in the static build because I have excluded the source for this from the static build. And if I was to do ifdef ep build dynamic around it, if my theory is correct, this should be sufficient to compile. And it looks like it is. Okay, so I think this is the scheme I'm going to be using. This is going to be something that you can include the header in your header block without having to worry about if-defing stuff in your header and cluttering up your header that way. But you do have to have compiler flags around the sections that's editor specific. That makes sense looking at a bunch of dots of light on a metal board. Yeah. That's technically correct. Um, However, there's a complication, like a user experience complication that I'm thinking of now that I've decided that this is something I need developers to do, is EP build dynamic around their stuff. The problem is that it's not very clear what this means. EP build dynamic. That's something that I've been using internally up till this point because obviously, if you're saying this is going to be a dynamic library build, that makes sense. Or if this is going to be using the dynamic library build, that makes sense to me because I'm the guy who is working in the engine. But if you're making a game, it's not really intuitive to say if def EP build dynamic. It should probably be saying something more like if EP editor, right? This would make more sense. You say if EP editor, do this editor stuff. Do I use any other EP build flags? I've got EP build dynamic, I've got EP build core. I've got EP build game as well. Where do I define EP build game? I guess I add it to the CMake list for the test game. Do I use it anywhere else? No, I pretty much just use it at the entry point. I mean, it's important. I use it to correctly handle the imports, because we have to export the symbol when you're using it as a module. Yeah, there's dynamic, core, and game. And that's it. I don't even have an EP build static. So what I could do is I could just rename EP build dynamic to be EP editor. I think that would be the smoothest thing to do. I always wonder what the life forms that don't see the screens like we do would think of us. That's an interesting question. Technically, you don't even have to look off of Earth, right? This isn't just a question about aliens. Dogs and hawks and eagles and cats, they all see different ranges of the electromagnetic spectrum than we do. Their cones are located. Their cones are responsible for different places on the EM spectrum. So it's kind of, that's kind of already a thing, and it's even a thing between people, right? Because there's colorblind people. There's people who have I forget the terminology, but there's people who have extra cones in their eyes, so they, technically speaking, pick up on colors that we don't exactly see. Like if we have standard RGB cones in our eyes, they just kind of see what they see and they live with it. I remember there was a discussion like in the early days of HDTV. For a long while, scientists had thought that dogs didn't have the ability to perceive motion on television sets because the refresh rate wasn't high enough, because their persistence of vision is apparently like way faster or something like that. So in order for them to perceive motion, like for us to perceive motion on a screen, it's got to be like at least 24 frames a second or something like that as the standard. Slower than that and it kind of looks like just a slideshow. But dogs like need a higher frame rate to see that. And so in the dawning of like HDTV, when they were starting to do like 60 hertz displays and 5997 television broadcast, that was like supposedly the time when dogs started to be able to detect motion on screens, which is an interesting thought. Before they were just seeing slideshows and they were seeing their people were staring at these slideshows on the TV and probably not necessarily putting together that they're supposed to be moving pictures. Yeah, I mean like life forms that can see every single light individually. Oh yeah, that's interesting. Have you ever seen the slow-mo guys on YouTube? Slow Mo Guys did a video where they did an up close of the LED screen, where they did a super slow motion video of the LEDs updating. Yeah, it's pretty neat. It's sometimes hard to imagine when you're looking at, like, the color purple on your computer display, to like realize that that's actually not purple. That's just various shades of RG and B very close together. It's crazy. Anyway, back to where we were. So I think we've got a good scheme going for this. However, I need to change this flag. So I'm going to do away with EP Build Dynamic entirely. I'm instead going to switch to saying EP Editor. And that's a little bit more... It's a little bit less accurate because it applies for everything that uses the dynamic build, which also includes the launcher. But if we just consider the launcher as like an extension of the editor, then yeah, I think this makes more intuitive sense from a user experience standpoint. So here's what we'll do. First, I will commit the changes we've made because I think that's all ready to go. And then I will do a quick refactor, renaming EP Build Dynamic to be EP Editor. And that'll make this a lot easier. A lot easier on the eyes, at least. Okay. So F7, make sure everything's building. Is everything building? There we go. And then for the sake of it, because I've changed a lot of files, I'm going to go into Terminal and run all my files through Clang format, just in case I missed one, which I don't think I did, but cool. And then in Git, I mean, could there be a Lifeform that can see every single light? What would they think? That we just stare at random things? Like, yeah, I don't know. It seems like I know from a physics perspective that that's actually probably impossible to have a Lifeform that can see every, because there's an infinite number of wavelengths in the electromagnetic spectrum. That's why it's a spectrum. But yeah, if you had like an alien Lifeform that saw like all of the wavelengths that we can measure, like and have that be like wired into their brains so they're actually perceiving it, that would be a crazy experience. They'd be able to see through walls probably, and things like everything that you can do with an X-ray, for example, like Superman's X-ray vision, that you can see through things. You can see heat. You could have predator vision. Yeah, that'd be crazy. It would just be an amazingly different way of life for somebody that could do that. Anyway, yeah, so just making sure that all of this is nice. So we have EP internal editor GUI input now for the input stuff. We've got... We're moving the input stuff out of the application folder because that's now going to be inside of the engine layer. IMGUI is now in angle brackets now because it's technically part of an external library at this point. Yeah. Good. Yeah. Good. Yeah. IMGUI. Yeah. These should be closer together. This needs to be staged, but not the other. of these can be deleted. Okay. Alrighty. Let's start adding these. Yep. Looking good. Yep. And Register Inspector GUI, we're not quite there. Not quite ready to implement that yet. But we will need editor.h, so I'm just going to go ahead and leave this as an empty file. We'll skip over that. And then GUI input. Set mouse cursor position needs to work. Yep. I shouldn't have quotes in header files unless they're internal source. So that should be like that. Yeah. And then commit U. If we could see better, like higher resolution or sharper, if we were really a close-up camera, as if we were watching a. I'm assuming you mean like a. Yeah, that's yeah. I don't know. There's superhero stories about people who have the power of this incredible vision. Yeah, it's ready to add. That's good. I've got to commit the changes for IMGUI first, I realized, because I have a dependency on it. So we'll come back to that in a second. Let me finish staging everything for this project. GUI is for Game UI, right? No, that actually stands for Graphical User Interface, GUI. So that's where the GUI part of IMGUI comes from. IMGUI stands for Immediate Mode Graphical User Interface. Cool, this is all looking good. Okay, these need to be... No, those need to be quotes, that's good. But we are not doing Register Inspector GUI. So what we'll do is we'll select everything except for this, and then we'll say stage selected ranges. And now we've staged everything. Oops, almost everything. Everything except for register inspector GUI, because that's not ready to implement. And we're not saving these changes to Renderer 2D quite yet. Okay, and no changes to the test game project are needed. All right, so we're almost done, but I had noticed that I had slipped up in some of my files and started using include in quotes on .h files. I guess I must have gotten them all because they're not showing up in my search anymore. So that's fine. And then inside of my CPP files, I need those to be I need those to all be in angle brackets outside of the engine project. Okay, so I'm good. Good. Oh wait, I missed one. Missed one check. Okay, good. Yeah, we're all set. I gut check myself an awful lot when I go to commit. Okay, good. So that's everything staged for the enterprise repository. But before I do that, I actually do want to get the changes to IMGUI pushed, because those are these changes are going to be part of the enterprise commit that we're pushing. We're going to be changing everything all at once in one commit for enterprise. So yeah, that's looking good. That's also looking good. Though admittedly, this kind of belongs up here. So the organization is that we've got enterprise, events, window, GUI, then GLM, and then this is my stuff. Then the rest of it was already here for IMGUI's stuff. Cool. Let's stage that. First, let's rebuild, make sure everything works the way that it should. And then I'll stage these changes and then stage the update to IMGUI as part of my enterprise commit. Good. Everything builds fine. We'll say updated we'll say updated enterprise input header path. Sounds good, Julo. Get some rest. Hope you feel better when you wake up. Cool. Now we've got a commit made to the IMGUI. I'm going to go ahead and sync those up now. So those are going to be on GitHub. And in the enterprise, we've still got all those changes staged from before. But now I've also got to stage the IMGUI changes. So this guy. Yeah, I think that's it. We're good to go. Well, there's GUI input.cpp. Hang on a second. Oh, I haven't staged this guy yet. So let's do that. Okay, so now we're good to go. Cool. And we'll say moved dear IamGUI to engine project. That was actually a pretty major change. But yeah, it's everything's kind of smooth, and we've got a pretty decent arrangement going. So this will make things make it quite a bit easier to do IamGUI code or editor specific code in the game project without having all of the overhead of the actual editor's headers and things. Cool. So let's. I'm not going to sync this up quite yet. There's a non-zero chance that I'll want to come and retroactively affect this commit. I generally will only push when I'm sure I'm not going to need to make changes. Because sometimes it's sometimes you don't realize until after the fact that you probably need to amend a commit, so I don't immediately go to syncing it. But yeah, so now we've got the hard part done, which is organizing, coming up with a plan for how we're gonna do this system integration, and then actually getting the IamGUI stuff moved over correctly. Hey, what's up? Yeah, we just migrated. I guess you can consider this a refactor. We just migrated IamGUI from the editor project to the engine project, so that way it's available for game developers to extend the editor with. And we're gonna start on that API now. How's it going with you? Cool. And I'm gonna be renaming this particular macro to be EP editor. So that way it's a little more user-friendly for game developers, now that I'm going to require game developers to use it. All right. Looks like this is all pretty safe. Yep. Replace 161 occurrences across 33 files with reckless abandon? Yes, I would. All right, F7. Let's see if it's see if I broke everything. That's interesting. I pressed F7 and nothing's happening. Okay, it was just stuck on the first time I pressed F7. CMake build. Okay, build files have been generated. F7, please. Rerunning CMake. Okay, and now we're building 110 files. That's not as bad as I thought it would be. I was changing a core, a very basic low-level define that I use absolutely everywhere, and we're only rebuilding half the engine. I'm taking things slow. Depressed hit for a couple of days. Don't worry. Oh man. Well, be sure to take some time for yourself. It's yeah. I think a lot of folks since COVID and everybody had to get locked at home. I think everybody's started to get a little bit blue. Oh, my cat's opened the door. Hey, kitty cat. You want to come say hi? Yeah. I didn't fully close my door, and the cat just swung it open. But yeah, important to take time for yourself. Make sure that you're running on all cylinders. Anyone could say hi. We're just compiling. Yeah, alright. This is Gordy. Want to say hi? My sister's cat, not my cat. When I'm offline, he likes to lay on my lap while I work on the computer. Yeah, he's Ginger. Yeah, he's a cutie pie. He's a rescue. He's probably pretty old at this point, but we're not sure. Okay, compilation seems to be working pretty well. We're at 108 out of 110. Cool. And that's working. And if we build it and run it, does everything work? Yay. Okay, the standalone game works. The editor, does the editor work? File, open scene, scene file, got the scene, got the things, and we can do the stuff and whatnot from before. Make them really big and tall and yeah, spin them around and stuff, and yeah, cool. All right, that seems to be an easy enough fix. So now the idea is that when you go to, if we go to test game again, I'm just using this file as an example of how you might use this in game code, even though it's not a system. Basically, when you want to extend the editor, you just go enterprise/editor.h or whatever helpers you need inside of editor/. And then once you've included it, and you've got a function that needs to do stuff like this, you can do ifdef ep editor. Uh-oh, get down from there, kitty. I'm gonna close my door real quick, hang on. One time, the cat was just trying to get my attention and wound up jumping on top of my, I have a server-style computer case, and he just jumped on and pressed the power button and literally just shut down while I was working on. And I was like, okay, I guess you have my attention now. But yeah, we basically say ifdef ep editor, and then we can do editor specific things like editor, register inspector, whatever, which we don't have in here anymore. All right, I think that's better. Because I just did a search and replace for all the files, I should run Clang format on all of the files again, because there's probably going to be some formatting differences as a result of the now smaller macro. And then with that done, I'll let this build in the background, but I'm going to go through and look at all the changes and get them committed. Yep, that's looking fine. Looking good. We're still skipping Render 2D's extensions because we're not really ready to work on it yet. Yeah, looking good. Yeah. Yeah. All of these should be pretty basic. Yeah. Yeah. Okay, that whole folder. Skipping over that one, over this one. This one's got a bunch of them. Yep, that's good. That's also good. Cool. Good. This part's admittedly a little bit tedious, but I do want to just quickly visually check that everything is a-okay, that I didn't do any weird, I didn't make Clang format do something weird because I shortened the length of the macro somewhere. That's looking good. Yeah. Yeah. Uh-huh, good. And good, yep. Getting there, nearly done. That's interesting. There's a couple of places where I have EP build Dyn as the symbol in the comments, even though that's not correct. And it never was correct. Okay, I guess it's just here. So I'll fix that. All right. Yep, and awesome. That's all looking good. Stage those. Not stage those. Stage that. Not stage that. Are you doing anything fun today? What's up? You seem very careful with git commit. For me, git add dot, git add dash m stuff is the way to go. Yeah, it's for a while that's what I was doing. I've gotten to be rather careful about that because of that attitude has gotten me into trouble in the past, where I've had to do commits just to fix things that I unintentionally broke by not double checking myself before making a commit. And of course nowadays I have to consider style as well. That I don't want this to be, I don't want to be doing something that makes the code harder to read, because one of the big things, one of my big design goals of this engine is to make it easy to read, make it easy to dive in. So I'm taking a lot of great pains to make sure that everything that I commit is exactly what it should be. Yeah, I could probably be a little bit more easygoing with this. At like a company, for example, what a lot of companies will do is that you'll have changes, you'll submit a pull request, and then somebody will do this process, like either with you or on their own. They'll go through and check everything and make sure that everything is fine before they go to stage it, or before they go to accept the pull request. But I don't have anybody doing that for me. I've got to do it myself. I wonder what this is about. Did I make a change to IMGUI? Did I make a... I don't remember making a change to IMGUI. But it says that IMGUI is dirty. And I don't know why. What's... Oh, okay. Yeah, IMGUI itself has an EP editor. Has an EP build dynamic in its header now. Yeah. This is obviously a branch of IMGUI. This is not part of the core, the actual library. I added it to make my things work. So I do need to commit this and then do this one first and then stage the change to enterprise. So we'll say rename EP build dynamic to EP editor. Commit and sync that up. Yep. Cool. And then back in the enterprise repo, we will stage this change as well. Okay. Good, good, good. I think that's it. I think that's everything. Okay. Yeah, that's everything. So on this commit, we'll say renamed EP build dynamic to EP editor, like that. Okay. Awesome. I've been playing Game to Relax. My EDYNE Array 2 is almost complete. Only a couple of copies constructors left to go. I've been thinking about an asset manager, async file IO. Probably will just stick with Boost ASIO. Yeah. With async file IO, you know, that's pretty low level. I think Boost is pretty useful for that. When it comes to like the actual management of assets, that's probably a bigger topic than you'd anticipate going in. There's a channel that I have started to watch recently, Twitch channel, and I don't remember off the top of my head her name. I think it's like Zai something. Let me find it. Yeah, Zybite VTV. I'm gonna link this into the chat.
This pepperoni did not get here by accident.
All right, I'm gonna link this into the chat because I think you might find this interesting. But Zai is a game engine developer that is currently working on a Vulkan game engine in the D language, which is an uncommon choice. D was intended to be a successor to C or C++, but it just didn't receive wide enough adoption. But she's using that to make a game engine that's centered around Vulkan. And I think it was either last stream or a couple streams ago, there was this big old conversation about like exactly like about asset management and like how to best like the best approaches there are for managing a whole bunch of resources, because she was modeling her asset manager off of Godot, and Godot has like calls everything a server, even though it's not technically a server. It's like it fulfills requests, but it's not actually like off of the machine. It has some confusing terminology, but the idea of like centralization versus decentralization for your asset loading and management, that's a very complex problem, and it's one that I'm just kind of like sidestepping for the moment, but I'll eventually have to dive into that myself. into figuring out like how to extend the asset conditioning pipeline and things like that. Okay, so I think we're at a good point. I've got these last two changes have been the big refactory part of this transition. So now inside of the engine code, inside of the game code, and inside of the editor code, I have access to DRIM GUI. And that makes it possible for game developers to extend the editor using DRIM GUI, which is the most important part of this. So let's go to renderer2d.h. This is where we've got the current currently the only system that we've got set up so far. It registers the sprite components to the scene manager, and it also registers a draw call, which is the reason why when we go to open up a scene inside the editor, the reason why we see anything. The renderer 2D registered a component type with the scene manager. When we go to load the scene file, scene manager calls the deserialization callback on renderer 2D, which then populates its memory with all of the sprites and the textures and everything that it needs to display these things. And then when we go to draw the scene, when the editor calls scene manager draw scene, scene manager knows that renderer 2D has to have some code executed, and it invokes its draw scene function, which actually puts all of this stuff in world space, and you can see it. So our challenge now is to take that one step further and have the renderer also extend the inspector. So we have the transform component or transform section of the inspector already. That's something that's native to all components. We want to be able to extend this and add another section for the sprite component type. So we're probably going to need to add this to the new fangled editor.h. This is the public-facing editor API. So this is how we would normally interface with the editor from a game project. And from here we would say, from here we would go to the CPP file, and we're using, I think this is the name I'm going to settle on, register inspector GUI, because it's not very ambiguous. And we basically just need to register a callback for drawing the GUI. And then this callback, once it's registered, will be called back by the editor after the fact. So we'll also need access to editor.h in the protected layer, and we're going to add some state here. So let's do I wonder if I should do a type def on this one. Let me real quickly, I'm going to generate my, oops, that's not right. I'm gonna real quickly generate my, what's happening here? Control. There we go. Gonna real quickly regenerate my documentation, and just quickly round up the type defs that I've already made for function pointers. So I think that's, and I think I've got a few already. Namespace members, type defs. Okay, so we got the serialization and deserialization functions. We've got event callback pointers. Yeah, we don't really have a pointer type for this. So you know what? I'll do a type def. I think that is reasonable. So I'll do inside of the editor.h. So the public facing one, I'm going to do type def. And this will be, if I'm remembering my C pointer type def format correctly, I think we just declare the type with a name. So I think it's like inspector GUI. That's not how you spell inspector. INSPECTOR. Inspector GUI callback, maybe? I don't know, what the hell. And then we'll do a return type of void. And then inside of here, we do the star before the name. And then we do the parameters, which is nothing. I think that's all we need to do. Is that legal? It might be, but I'm not 100% on that one. Oh, did I close? I closed my docs already. Let me regenerate and reopen. Yeah, that's all you need to do. Okay, so we've got a type def for a void that returns whatever. We'll say register inspector GUI function, and then it'll accept a inspector GUI callback. Like that. Excuse me. I might rename that later. And then inside of the EP internal, I need to save this as state that's going to be visible inside of the launcher and inside of the editor specifically, but not visible to the game layer. So from here, we will do, I guess it makes sense to do this as a vector. We iterate through it when we go to do callbacks on it. We don't need to do any sorting or anything like that. It'll just be whatever order the systems were registered in. So we'll just do an STD vector here, which means, of course, I need to include vector. An STD vector of that callback type, because this has to be public and this has to be private. I do have to cheat a little bit, and I'm not going to use the actual type, or the actual type def here. I'm just going to do a type like this inside of the vector template, because this is the same thing, but I don't want to have circular includes here, and I want this to be private and this to be public, so that's how it is. And this will be the inspector GUI callbacks, like that. This is going to be an extern, so that we can define it inside of the CPP file. And we also need this to be visible to the editor, so we need to do EP API to export the symbol. And we've already got shared library exports.h included, so that'll take care of that. Cool, and then we need to go to the editor.cpp, and then in here we'll do the definition. And then instead of doing the type itself, I can actually, because we have access to the public header in this case, I can actually do the type. Oh, hang on. I got it in my head backwards. I don't actually need to do this thing here. I can actually use the correct type. I got it in my head that the public included the private, but it's the other way around. So I can just do this. Cool, and then I can do that. So we got inspector GUI callbacks to store the callbacks as we register them. Cool. All right, and now we just need to do the register callback, which we've got going on right here. So register inspector, that's not spelled correctly. Register inspector GUI. Actually, was it GUI callback? I'll copy and paste it like that. Cool. And it accepts a inspector GUI callback type now. Cool. And for that matter, this needs to be exported. EP API on this. And then the type def is something that you just do in the header. It doesn't need to be exported or anything. That'll just be available in every file that includes this header. Perfect. Now in here, this is going to be really complicated code. Are you ready for this? It's going to be inspector GUI callbacks dot pushback. And now I need to actually have a name for the thing. Callback. Yeah, and that's it. So this is going to be invoked at the system registration, generally speaking. This will add it to the list, and then on the editor side, the editor has access to inspector GUI callbacks and can invoke each of them in turn from the inspector view. And so inside of the inspector view, where we've already got the transform stuff, after we've done the transform, we'll just iterate through this vector and call back all the callbacks. I'm wondering if I should... Let me head to renderer 2D real quick. You could argue that the cleanup function for the system should also have an unregister function, but I think I'm going to skip that. What I'm going to do is that on the editor side, when we go to reload a game module, we're just going to start over. We're going to dump this entire list and then start over. Though to be more correct, maybe I should make this something that's handled automatically by the engine runtime, considering that this is part of the engine project now. So I'm going to add a function. Let's do that. To EP internal. I'm not going to export this one. I'm just going to do the function directly in here. We'll say void clean up. And this will just be cleanup for the editor namespace stuff inside of the engine library. And then in here, we'll implement it. And for now, it's just going to call inspector GUI callbacks dot clear, clearing all that out. So this is going to be available inside of the engine layer. And then on the runtime for the engine layer, we will invoke the cleanup. Okay, so this is the destructor for the engine runtime. When it's time to clean up, we will clear that list. So we clear the command line option data and pass it through again. And then we will invoke editor cleanup. And for that to work, we're going to need to include that in here. EP internal / editor.h. Yeah? Are you gonna fix? Okay, there we go. Cool. So now that should work fine. I think we're off to the races. So now we have a mechanism by which we can register a GUI callback. I'm going to go back into renderer 2D, and inside of the init call here, where we register the scene draw, we register the component type, I will now invoke editor. Well, I need to include the header first. Let me do that. Include enterprise/editor.h. And then down here, I can do editor : register inspector GUI function. And I'll say on inspector GUI. And I'll declare and define that up above in a second. And so after we go to register the scene, it will register the extension to the editor. And like we were talking about before, we're going to need to wrap this in EP editor whenever we're doing something that's editor specific. Cool. All right. And then I need to do a function up here. I'll make a static void on inspector GUI like so. And this is going to be what we call whenever we go to render the inspector. Whenever we go to render the inspector for the sprite components. So this also needs to be wrapped in an ifdef because we're going to be including IMGUI code in here. But just to confirm everything's working, I'm going to add a simple. Here we go, IMGUI.h. I'm going to add a simple thing to this code. I'm going to go to. I think it's going to be IMGUI header or collapsing header, I think, and we'll give it a label sprite and pass in IMGUI tree node flags default open. So this is just going to produce the header the way that we had in the transform component, and I'll save that. Cool. So for starters, let me just make sure everything compiles. And assuming it does, we'll go into the editor layer and we'll get it to actually start calling this stuff. Okay, there is a problem. Fatal error, IMGUI file not found. That's surely an error with the static build. Let me take a look at that. CMake lists for the engine. Those others. IMGUI is going to be inside of editor source dynamic. And then it should also be in, yeah, here. Target include directories. Okay, so target include directories, I do need to include this in the engine library, probably. So what this is going to look like is that when you're working on the static code for your game, it's possible for you to include to include one of the IMGUI headers, but it should fail to compile if you actually use anything from it, which is the strategy we've been going with for the editor headers that I supply as well. So hopefully this will just fix that. Yeah, configuration is done. F7 to rerun and build. It's looking better. I got a good feeling about this. While that's finishing, let's go to the editor now. So we'll go to inspector.cpp. We'll include EP internal / editor editor.h. And then from here, we should have access to the private stuff. So we should have access to inspector GUI callbacks now. Cool. And that compilation finished like normal. So perfect. So this is the code we were working on the last couple of streams. We've got the transform component. And I scoped it into its own block so that way its stack allocated stuff doesn't remain for the other components. And now, here's the magic part. We're gonna do a for loop through these. So we'll say for callback or auto callback, so const auto reference callback in inspector GUI callbacks, and we're already inside of the editor namespace, so we don't have to do any scoping. We would just invoke a callback. And that should be it. So inside of the, to recap, inside of the system code in its initialization section, we invoke the register inspector GUI function. And then we, inside of the editor in this section, we will just run it. So this will run regardless of whether we have anything selected. It doesn't do anything yet, but it's a start. All right, let's run and see what happens. Open up a scene. Okay, so we've got the inspector now. Take a look at that. Okay, now we've got a sprite section in the inspector for the renderer 2D system, which is great because that's baseline shows that we do have the system itself adding a section into the inspector where it's able to make its own GUI, which is, yeah, that's pretty cool. That's pretty cool, right? I think I'm almost out of steam for this stream, but let's see if we can't do a little bit better with this. If we go to renderer 2D, its implementation of on inspector GUI, at this point we haven't really decided what we're going to display yet. So I guess we're going to need some information back from the editor. We're going to need to know what's selected first of all, and then we can do the IMGUI code that would edit the data, the state that's held by the system. So we're going to need to change the prototype for the onInspector GUI functions. Instead of just being static void, or instead of just being void and then accepting no parameters, we're going to need to accept a list of entities that are selected. It would make sense for this to be a set, I think, because it's already a set inside of the editor layer. Because selected entities itself is a set of entity IDs. So if we made a set reference, like a const reference to this set, then we could use that. Let me do that. So inside of here, we'll need access to include enterprise cmanager.h. I mean, technically, I think it's transitive include, but I'm not interested in transitive includes. And in here, we will change this to be an std set of scene manager entity IDs, and this will be by reference. It'll be const, and it'll be selected entities. Yeah, and then we need to set this as part of the prototype that we use for Inspector GUI callback. So Inspector GUI callback is now going to take const std set of scene manager entity ID references. And for that to work, we need to include a few things. Include enterprise scene manager.h, and then we'll also need to include set. And that should be enough to resolve that warning. Come on. Oh, except for this is not in the enterprise namespace, so we do need to do EP like that. Cool. Good, save that. And that should resolve the warnings in here. Sweet. And now in the inspector, we need to pass that pass that through. Hey, Olin. I envy your focus and dedication on your project. I'm having a hard time just coding for 1 hour low. Yeah, I do too. And to be honest, streaming is actually really helping me stay on track. When I'm by myself, I tend to be way more distractible. That doesn't always work. Sometimes if I'm talking with you guys, I get distracted from what I'm doing. But I think for the most part, like while I'm actually have a camera on me, I have this this switch that goes on in my brain, like I'm on the clock, I gotta be working, and that helps. But yeah, we need to be passing in, when we invoke the callback for the Inspector GUI callbacks, we now need to be passing in the selected entities, which is the set of entities that the hierarchy tells us are selected. Cool, okay, that's good. Let's make sure that compiles. It probably will, but I always gotta double check myself. Cool. And then inside of here, we can actually do stuff with the selected entities list. Yeah, that compiled just fine. Cool. So I guess what we need to do is we need to iterate through the selected entities. So we'll say for const scene manager entity ID const reference entity out of selected entities. Like that. So we're just gonna use the range-based for loop, get every entity out of the selected entities, and then we gotta decide what to do with them. I think for now, I don't know if I want to actually get the GUI for the sprites done this stream. I think that's going to require a bit more thought than I want to spend the time to do right now, because I've been live for 4 hours already. But I'll at least confirm that I have the selected entity list showing up. So what we'll do is we'll do IAMGUI header, collapsing header, give it that name, sprite, for the sprite component. We'll give it the IAMGUI tree node flags, default open, so that way it's automatically expanded the first time we go to see it. And then we have to do an if on that, like so, so that way, so that we're only executing this code when the header is not collapsed. And then I guess we would do a IAMGUI selectable. No, IAMGUI. Yeah, I'm gonna do an IAMGUI like a text item. And then I'll just do I don't know. I'll do the string name of the texture for every entity that's selected. Because my priority here is not to make something useful. It's to make is to confirm that I've got the data I need to make a GUI for this system. And this will be, we'll go to, I guess we'll go to scene manager, and we'll say get entity name, and we'll pass in the entity ID. Yeah. Except for I don't need to do a formatted string here. What I can actually do is I can just do .cstring like that and pass that in. Yeah, I think that's good enough. So what this should do is that every frame, when we go to update the inspector view, it'll list the, well, get an entity name is a little basic. I mean, it'll work. It'll print off the name of all of the selected entities, and that'll at least confirm that we've got the correct entities showing up in the GUI. And assuming that works, then that's where we're going to call it for today, because it gives us the ability to craft a GUI for each system. Cool. So we've got the scene loaded up, selecting these sprites. Okay, that's interesting. Yeah, so it's working technically speaking, but what I forgot to do is I put the header in the for loop instead of outside of it. So that's a simple enough fix. I would just move this part outside of the for loop, reformat, and then F7, and then build it again. But cool, yeah, it looks like it's in principle it's working. We've got a system by which, or an API by which a game system can register to extend the inspector and then do it. We can see the names of the entities that we're asking to handle being passed to the renderer 2D. This is great. we're off to a great start. What we would do the next stream, and I don't know whether, I think I'll probably wait until Monday to do my next stream. But the next thing that we would do would be to actually get the renderer 2D to actually do something useful in here. And at that point, I think we would actually start to make changes to the renderer system so that it's a little bit more like a general purpose renderer. Because eventually it will be. It'll be a default basic, quote unquote, basic renderer that you can use until you make your own, or instead of making your own. And it'll at least be a proof of concept for getting the inspector to do what it needs to do. Sweet. Yeah, but that was something. It was not exactly straightforward getting to this point, but here we are. I always get tripped up with this, because whenever I go to play around with the rotations, I always look at these and think that they're rotating at different speeds. But the truth is that this is a 3D perspective, and there's foreshortening going on that I don't really pick up on until they're rotating. So like it almost looks here like Hollow Knight is like a little bit more flat than Madeline, or like they're not quite the same angle, but they are actually the same angle. It's just that the foreshortening screws with your perspective. Like when I get back to 360 degrees, multiples of it, it should be, it should be back to vertical on all of them. All right, cool. I'm rambling. Thanks for popping in. I probably will return to streaming on the engine on Monday, but we'll see. I gotta get a schedule going. I gotta actually lock down when I go to do this stuff. Thanks, what's up? I hope you have a great day as well. Talk to you later.